Hello everybody, my name is Tom. Welcome to the channel Data with Tom, where I make easy to follow and applicable videos in the data and AI space. In this video, we're going to be working on a machine learning pipeline that is all in Snowflake. This project should be applicable to people that are new to Snowflake and people that are also new to machine learning. I'm going to be walking through step by step in an easy to follow way. Everything that we do should be covered by the Snowflake free tier. What are we going to cover in this video? We're going to talk about the basics of Snowflake's UI and running some SQL commands. We're going to load data into Snowflake, and to do that we'll use Snowflake Notebooks. We're going to do some model training and testing using Snowflake's machine learning Python package, and we're also going to use Snowflake Model Registry with that model training and testing. We're going to create predictions with the model and write them to a table, also using the model registry. We're then going to turn all of this into an automated pipeline in Snowflake using streams, stored procedures, and tasks. Now, everything that we go over today is going to be contained in this GitHub repository, Snowflake Train Inference Pipeline. I'm going to have the link in the description. As you can see, there's the README to orient yourself, and then there's two folders, create locally and create in Snowflake. Today we're going to be following create in Snowflake because we're going to do everything using the Snowflake UI. If you want to do it locally, you can execute the code on your computer connecting through Python to Snowflake. So that's another option, but I wanted to keep it simple for this video. Let's take a look at what a typical machine learning workflow could look like. We're going to start on the left here. We have our full data set. Now, in our case, we're going to be using insurance data. So data about people, their demographic information, their age, where they're from, if they're a smoker or not. The variable that we're trying to predict is the insurance premium, the charges in this case. And so we have our full data set of 1 million records that we're going to get from Kaggle later on. For our flow, we're going to split this full data into a training and testing data set of 10,000 records, and then a simulated incoming data source of 990,000 records. This data set down here is to simulate as if there was like a streaming service bringing in data continuously. Let's say you're Geico and you have your website and you have your app and you have insurance salespeople, right? All of these people, all of these applications are creating data, creating records of customers, and those records would be coming into your machine learning pipeline, and you'd want to predict the charges as they come in. Okay, and so all this data set is to simulate having those external data sources streaming in. Now let's go back to the top. So with this training and testing data, we're going to train and test a model. We're going to do that. Usually this is done in Python or R. We're then going to save it to a model registry and then load that model once we want to perform inference, or in this case, predict the insurance charges. Now let's go down to the landing table. If you're streaming records into your machine learning workflow, you'll usually have somewhere where those records are landing first. Once they're landed, usually what happens is you perform inference on these records every set number of minutes or hours, or once it grows to a certain number of records, you might then kind of process that batch, right? And so what that looks like is you grab records from this landing table and you load the model from the model registry and you perform inference. And so what that means is you're creating a column called predicted charges based on the demographic data of that person, or based on the attributes that you have of that person. You predict, okay, they're probably going to have a yearly premium of $10,000, for example. You then write all of that information, both the attributes of the person and the predicted charges, to a gold table. Now, this is very general. This flow could be done in Snowflake or in Databricks or in Azure ML or in AWS SageMaker. This is kind of a fairly typical machine learning workflow. Let's take a look at how we're going to accomplish this in Snowflake specifically with some of the vocabulary and specific services that are used in Snowflake. So we first see that we're going to use the same data. We're going to split it into a training and testing set, and then we're going to split it into a incoming data source. All of this we will accomplish using the data loading notebook that we're going to look at in a second. Now let's take a look at this yellow box, this stored procedure here. So it says use the data from the training data table and to train a model and save it to the model registry. What exactly is a stored procedure? A stored procedure is logic that you save to be called later on. In our case, the logic that we're going to use is logic to access data from this training data set, use some Python to train a model, and then save it to the model registry. That's what the stored procedure does. Now, what the task does is it every 8 days executes the stored procedure. So all it is really an automation and scheduling tool. I want to take a look specifically at model registry. What is that? What does it do? So in Snowflake, the model registry allows you to save your model artifact, save the model file, the model that you've trained, and you can give it a name. You can do version control on it, so you can see the multiple versions and access each of the different versions. You can save some sample input data to the model registry to see what kind of data that it's expecting, and associated metrics, so the mean squared error or accuracy or precision. So you're able to easily see some of the performance metrics of the model. Now, what's really special and what's really cool about the model registry in Snowflake is that once it's saved to the model registry, you're able to call the model with using SQL from a normal SQL worksheet or using Python. You don't have to set up some kind of inference endpoint or anything. It's just ready to go once it's in the model registry. Okay, now let's move on to the bottom. We're going to first take a look at this green rectangle that I've added called a stream. So in Snowflake, a stream is a way to capture change data capture. And so what happens is anytime there is a change to the records in the landing table, whether that's an update or delete or an insert, the stream reflects that. I kind of like to think of streams like buckets. You know, it's a bucket that when there's a change, that change gets put into the bucket. You know, that record gets put into the bucket and it says, hey, you know, this row was changed in this way, just so you know. Okay? Once you do something with that record, once you do something with that change, you grab from the stream and do something with that, you know, pass it to the gold table in our case, then the bucket is empty. When there's a change, the bucket reflects that change. And when you scoop into the bucket and grab that change and do something with it, the bucket is now empty, right? So that's what a stream is, okay? And that'll come in handy when I talk about this the stored procedure and the task. The stored procedure, again, is just saved logic that we will call when we want to. In this case, the logic loads the model from the model registry right here and uses it to predict the insurance charges and then writes that data to the gold table. The task that calls this stored procedure is a little bit different than the task above. In this case, the task every minute checks if there's data in the stream. In other words, sees if there's anything in the bucket. If there's nothing in the bucket, it doesn't do anything. But if there is data in the bucket, or in other words, if there have been changes to the landing table, execute this stored procedure and access the data from the stream, perform the inference, and write the data to a gold table. So there's a little overview of what this is going to look like in Snowflake. As we go, I'm going to check off what we've done, and we're going to refer back to this frequently so that we can have a good idea of the big picture of what we're doing. Okay, let's head over to Snowflake and set up our account. You can Google create Snowflake account and go into a Snowflake trial, fill out this form. Here we can choose the Snowflake edition, standard, enterprise, business critical. I just go with enterprise and AWS. I'm going to use the US West Oregon region. It doesn't really matter here. But then once we click get started, you should get a link to your email to then access your Snowflake dashboard. Okay, here's the Snowflake UI. We're going to first look at the data menu where we can see that there are a couple built-in Snowflake databases. We're going to add a database here in a second after we look at some other things. There's also the monitoring tab where you can see query history, copy history. When you're from loading in tables, you can monitor tasks that you've run. We're going to take a look at this later on. Here in the admin pane, we're able to track our costs in Snowflake. We're able to look at our warehouses and create compute instances is basically what this is like. We do have a built-in warehouse called Compute Warehouse that is an extra small. The sizes for Snowflake are super simple. It's just t-shirt sizes, and the amount of credits that you consume per hour just doubles with each size. And so you go from extra small all the way up to 6x large. And you can also choose between a standard warehouse and a Snowpark optimized warehouse, which is basically offers more memory if you're doing memory intensive things like machine learning. But for this tutorial, we're just going to use extra small to keep our costs low. Now let's take a look at the Projects tab. In Projects, we can see our SQL and Python worksheets. We can take a look at notebooks that we've created, Streamlit apps, dashboards, app packages. We're going to be working with notebooks and worksheets in this tutorial. Now let's take a look at the Data tab. As you can see, we haven't created any databases. Let's start by pasting in the SQL from the GitHub repository so that we can build out this pipeline. So we'll create a SQL worksheet, and if we want to, we can rename it to ML pipeline. Let's head over to the GitHub repository to grab the SQL code that we need. So we're going to go to create in Snowflake and then SQL to build pipeline. And we can just click copy on this. I'll zoom in a little. Paste it in, and then this is all the SQL code that we'll need for this pipeline. We're going to run through it piece by piece. So first, let's just create the database insurance. And if we refresh this object viewer over here, we can now see we have an insurance database. The information schema and the public schema are both just built into the database once it's created. We're going to create the ML pipe schema, and really what a schema is, if you're not familiar, it's almost like a folder. It's just a way to organize your information within the database. And so now we have an ML pipe schema with no objects in it. Okay, now we'll create the table that we're going to use as our source of truth data set. So I specify columns and their data types here, information about people that we're going to use in the insurance predictions. I want to point out here that this charges column that we have is going to be our outcome variable, or our predicted variable that we're trying to predict. And so in this case, we already know the charges. That's how we're going to train the model, is showing the model, hey, here's this information about this person and here's what their charges were. Train yourself on that, understand that. Okay, we've created this table. There's not data in it yet, but we have created it. We're now going to create the incoming data source table. So that one has been created. Check that off. Okay, once we have those two tables created, we can now load data into them using the data load notebook. So as the code says, in this notebook, we load our full data set, the 1 million row data set, into Snowflake, then insert 10,000 rows into the source of truth table and 990,000 rows into the incoming data source table. So let's go over to the GitHub where the data load file is. You can just click on it and hit download. That'll download onto your computer, and we will go into notebooks. So I'm going to open up a separate tab here for notebooks. You can click import from Python notebook file, click our notebook and upload. We can rename it to load data, choose the insurance database and our ML pipe schema, and then run on our warehouse, our compute warehouse. Something I really like about Snowflake is that it very, very quickly connects to your compute instance. And if your compute instance isn't running, it starts it, and it's very quick. So we're first going to start by downloading the dataset from Kaggle. So we'll go to this link. If you're not familiar with Kaggle, it is a website that has datasets, and they run kind of machine learning and data science competitions to see who can get the closest or who can solve the problem the best, right? So we have this dataset is made available to us by Sridhar Streak's account. If we just click download and then download dataset as zip, you'll need to create a Kaggle account, and then it'll download onto your computer. Once we have the dataset downloaded, we're going to load the CSV into our notebook environment. And so to do that, we click Files, we'll click the plus here and upload our insurance dataset. Okay, once that's completed, we can now run the rest of this notebook. So let's just click play on this. First, we're creating a Snowpark session. Now, Snowpark is the way to connect to Snowflake programmatically using Python, Java, or Scala. And in this case, we're using Python, obviously. By creating this session, you're able to perform actions within Snowflake using your Snowflake compute. And so say you did this locally, or you're doing the local version of this GitHub repository. Whenever you're using Snowpark and performing queries or creating tables, things like that, you're not actually using the compute of your local computer. You're never bringing data down onto your computer. You're always using your Snowflake and the data stays within Snowflake. And so it's a very secure way to interact with Snowflake programmatically from your local machine, or in this case, within Snowflake itself. So first, we're going to load the data from the CSV we downloaded into our environment into a pandas data frame. So we'll run that. Now we will perform some cleaning and rearranging of columns, and then we'll use Snowpark's write pandas method to write the first 10,000 rows of our data frame, of our pandas data frame, into the source of truth table in our associated database and schema. So I'm going to zoom in just a little more. So we click play on that. Should only take a second. Yeah, took 2 seconds to load in 10,000 rows. And then we're going to do the exact same thing, but with the incoming data source table. So those 990,000 records. And we do get a slight error here. It's really just about an index. You know, the indexes are different than what it expected. But if we take a look at our databases, we look into insurance, we can see some metadata about these tables. We can see that if we refresh, there are, yeah, we can see the rows got loaded in 990,000 rows in that table, and I guess it's taking a sec, and 10,000 rows in this table. Great, so our data is loaded in. We can now, I guess, check off this one. We can check off that we've done all of this, right? So these are completely ready to go. Now let's take a look at the model training and testing aspect of this pipeline. Before we go into the code, I wanted to touch on a little overview of what Snowflake ML is, why it's good, why we're using it. And so I have this little diagram written up or drawn up. So when it comes to machine learning, you are using an algorithm. You're pointing an algorithm at some data and saying, look at this data over and over and over and train yourself so that you're able to classify or predict or group things together and really just find relationships in the data and utilize those relationships to predict future relationships or predict future outcomes. Lots of times in data science, we're just doing that locally on our own machine. And if there's not that much data, then it's totally fine. But the whole point of using Snowflake is that you have monstrous amounts of data. You have millions and billions of rows. And so what Snowflake does, what Snowflake ML Snowflake's machine learning package allows you to do is parallelize both training jobs and predicting jobs or inference jobs. So we can see, I mean, this is super basic and rudimentary, and it's a lot more complicated than this, but really what happens is when you say to Snowflake ML, hey, use this training data set and train a model, and well, in our case, we're going to be doing hyperparameter tuning, and which means we're training several models. We're training many iterations of a model. You're able to give each computer a model to work on, and they can perform those training jobs in parallel, and then determine what model is the best and output that final best model. Okay, and so what that does is it saves you a lot of time, and time is money, especially with cloud compute, right? And so if you're spending less, if your job takes less time, you're going to spend less on compute. And so this parallelization saves you time and money. It's the same thing with prediction jobs. When you say, okay, here's a million rows of data, for each of them, predict the outcome variable, predict the insurance charges in our case. It can create a vectorized UDF and parallelize those operations so that multiple compute nodes are handling those instead of just one. And so it goes a lot faster and saves you time. Another tool that Snowflake Machine Learning provides us is with this pipeline object. Now, pipelines exist in other machine learning frameworks like with scikit-learn, and Snowflake's implementation is very similar to scikit-learn's pipeline, but it's a really cool thing that I wanted to kind of teach a little bit about because we're going to be using it later on. I like to think of pipelines like little factories with a conveyor belt that, there's this station that does this thing, there's this station that, puts the doors on, there's this station that puts the wheels on. A pipeline is similar in that there are steps of the pipeline, and at each step there is an operation completed on the data. Now, this diagram shows us, let's just kind of follow the logic of this diagram, right? So we feed it a training data set to the pipeline, and we say pipeline.fit. Okay, and what we're saying is, okay, there's this factory, there are these steps that need to happen. Let's give the data to this pipeline in a way that the pipeline is ready to receive the data and understand the data and train itself, so that when in the future it receives similar data, it can perform the operations in the right way. This last part is kind of, when we think of machine learning models, it's this last part right here, the predictive model. And so in our case, we're going to be using an XGBoost model. So XGBoost model. And when we give it training data and we say pipeline.fit, it's going to do all these other operations, but the last part is that it's going to train a model. Okay? When we do pipeline.predict and we feed it testing data, or we feed it, production data that we want to perform inference on, it won't do the training on all these different steps, including the model. It will just do the transformations. So it will scale it, and it will do dimensionality reduction, and then it will predict the outcome, the insurance charges. I hope this was an okay overview. You can look into pipelines more just by looking up scikit-learn pipelines. Let me just type that out. Scikit-learn pipeline object. And there are several YouTube tutorials on that and documentation on that are probably a little more helpful than what I said, but I hope that this is a good overview. So what we'll be doing is defining a pipeline, or in other words, dictating what the steps of the factory will be. We will then train a pipeline, which gives us kind of this pipeline object, and we can then put that pipeline into the model registry so that in the future when we want to make predictions, we can just feed raw training data to the pipeline. The pipeline will perform all of the transformations and the predictions, and we can then write that data to the gold table. Now let's get a look at the big picture again. Let's take a look at our Snowflake diagram. We're first going to create this top stored procedure. And again, a stored procedure is just saved logic. In our case, we're going to create logic to grab training data from the model training data set from the table and train a model and save it to the model registry. And it sounds pretty simple. There's a good amount of code, and we're going to go through it right now. So let's head over to our Snowflake dashboard. Let's create another tab for worksheets, and we'll create a SQL worksheet. Here we're going to load in the code to create that stored procedure, and we get the code from the GitHub repository. So let's go back to create in Snowflake, and this stored procedure is under train and save model. So let's copy this code, let's paste it into our worksheet, and then with the worksheet you need to select your context within Snowflake. So let's set our database and our schema, and we can go ahead and click play on this because it's going to take a second to run. Let's go through this step by step. So create or replace a procedure called train and save insurance model. This procedure takes two parameters, two input. The first parameter is just a string that indicates what the name of the table is that we're grabbing data from. The second is a Boolean to indicate if this is a major version of the model or not. And we're showing that it returns a string. The language that we're writing it in is Python. The Python version we're going to use is 3.1. Here we specify the packages necessary for this Python stored procedure. And so we can see that we're using some telemetry, Snowflake Python, Snowflake ML, Snowpark, and XGBoost. We also specify the handler. In this case, it is train save insurance model, the name of the function that we're calling with this stored procedure. And then we go into the Python code. Now, the Python code doesn't look very good here in this SQL worksheet, so what we're going to do to go through it and see it a little easier is go into the GitHub repository, go into create locally, and pull up train and save model.py here in this folder. And now we can see that there's, it looks a lot better, right? A lot of this code is different than what we have in Snowflake because this is being done locally, and so we can just ignore that. But from here down, it's all the same. So in this file, we're using a lot of Snowpark. Now, if you're not familiar with Snowpark, it's very similar to Apache Spark, which is a way to manipulate large sets of data in a distributed manner. And Snowpark is Snowflake's implementation of Spark. It's a little bit different than Spark. There's a lot of similar functionality, a lot of similar packages, but a little bit different, right? We're going to be using Snowflake's machine learning package for Snowpark. So if you don't understand exactly what I'm going through, you can look up tutorials on Spark or Snowflake Snowpark if you want. I'll keep it at a very high level because it's not super important that you understand every precise line of code, just kind of the overall idea. If you want to, you can copy this code and go through it yourself and modify it and ask ChatGPT to explain things as you go, and that'll be a great learning experience if you want to. So we'll start by looking at this data loading part. As we can see, we're just accessing the data from the source of truth table by saying session.table source of truth limit 10,000. So in this case, we're grabbing all of the records. We then do some feature engineering. We specify the label column or outcome column, which in this case is charges. We then specify the feature column names and the output column name, which is predicted charges. We specify different types, and we specify what columns we need to do one-hot encoding for. And at a high level, one-hot encoding is just turning categorical columns, such as region, like if they're from the northwest or southeast, turning that column into multiple columns that represent that same information but in a numeric way. We then do some data cleaning, some capitalizing, removing spaces, and then here's where we get into the model training. And so this is really cool to me. This whole pipeline object, it's a relatively new concept to me, and I think it's super helpful, super seamless. We start by defining the pipeline object that we want to use. So we just initialize a pipeline, we dictate the steps, and in this case we have a couple steps that we're not using. I've just commented those out for now, and so the only two steps that we're actually doing are one-hot encoding and doing a grid search. Now, I explained a little bit about one-hot encoding is, so I won't go too into that, but what the grid search is, you know, with every machine learning model, there's, especially XGBoost, there's a lot of kind of knobs that you can tune to squeeze as much performance out of your model as possible. In this case, we're going to be tuning the knobs of number of estimators and the learning rate. With grid search cross-validation, we specify the different combinations of parameters that we want to test. So in this case, we specify 3 different values that we want to test with number of estimators and 3 different values that we want to test with learning rate. What Snowflake machine learning does, and what this grid search does, is for each of these unique combinations, which is 9, for each of these 9 combinations, we train an XGBoost model and determine its performance. And then at the end, we compare all of those 9 models against each other and select the best one. What's really cool about Snowflake is that it parallelizes this grid search across all of the available compute nodes, so that we're not just training on one compute node and waiting for that one to finish and then doing the next one, then doing the next one. They're all happening at the same time, given you have 9 nodes. It depends on how many nodes you have, but if you have multiple nodes, they're parallelized across that, which is awesome. We specify how it's going to score, or how it's going to determine the best model, and that's based on negative mean absolute percentage error. We specify the input, output columns, label column, and that's basically all it takes for running this pipeline, or to create this pipeline. So let's go back just a little bit to ensure we're understanding everything. The pipeline steps in this diagram are different than what we're using, but the concept remains the same. What we just did was kind of scaffold out this pipeline. We said, hey, this is what the pipeline is going to do, okay? Now we're going to do pipeline.fit. So we're going to split the data into testing and training, and then we fit the pipeline using the training data set that we just created here. So we say pipe.fit, because pipe was what we called our pipeline. So we say pipe.fit. And what that does is goes through and does the one-hot encoding, and then it does the grid search cross-validation using XGBoost models and testing all these different hyperparameters. This step takes a little while. We'll see exactly how long it takes. We have some telemetry. I'm gathering telemetry data, so we can see actually how long the pipe.fit process takes. Okay, so now we're going to do the model evaluation to determine some of its accuracy metrics. What we do is pipe.predict and pass it the testing data frame. It will then perform the parallelized inference like we talked about before. And so that'll be a very quick process. We then use those results to determine the mean absolute percentage error and mean squared error using these built-in functions or methods from Snowpark ML. Once we have those metrics, we can then save the model to the registry. And so this function here, it's just a kind of a helper to name the model using 1.1 or 2.0 to determine kind of the incremental versions. Right here, we're creating a model registry session, you could say, creating a model registry object so that we can then load our model into it. this is where we actually save the model. So we say we're creating a sample data frame right here with assigning that to X. We name the model, we set the version name using that function I looked at a second ago, and then we log the model to the model registry, giving it a name, giving it a version, passing in the sample data, and specifying the dependencies for that model. We then also set the metrics that we determined before, and then that model is then saved to the model registry so that we can access it later on. And the last thing we do here is we set the model's default version to the version that we just trained. So that's the whole stored procedure that we went through. I know that took a second, and there's probably some stuff that you didn't understand, but that's okay. You can use ChatGPT to understand it a little better. Let's go into Snowflake and see if our stored procedure created itself successfully. So that ran successfully. We now have a stored procedure in our schema. So if we look at stored procedure, so now we can see that the stored procedure is trained, or the stored procedure exists. So let's mark it off that it is created now. Stored procedure is created. Awesome. Let's go into back to our SQL worksheet where we're defining all of these pipelines. So we ran the train model SQL file to create the training stored procedure. We're also going to execute these two commands. Event table. Yeah, so what these does is this allows us to collect telemetry data so that we can understand how long each part of the model training process takes. Okay, we're now going to create the task that calls the training stored procedure every 8 days. This can be, I chose 8 days kind of randomly. This is something that you can play with, and the whole point of having a task to retrain this model is if you have new data coming in that can help amplify your model's predictive abilities, right? So, I mean, if you have the same 10,000 records over and over and over, there's no point in retraining. But in the real world, you would have additional information coming in that you're adding to your source of truth data that serves as data to retrain your model. And so that's why we have this task here, is for continual retraining. So we run this task. The task is created. They are initially in a suspended state, so we're going to say resume. Really quickly, before we execute the task, we need to go into this monitoring page and go to traces and logs. I'm going to open it in a new tab. And we need to click set event level, go into our insurance database and ML pipe schema, and I just click on for everything and I set it all the way to trace. And that will allow us to collect the telemetry data so that we can see the performance of our stored procedure. And we're going to have the task execute so that we can see how it actually works. So as you can see, we have in our schema, we only have a couple tables. We have the one task that we just created, and we have the procedures. If we go into the task, we can see some of the details about the task, a graph view if this task has dependencies or there are tasks that depend on it. We can see that in a graph view. Currently there's none. And then we can also look at the history of its runs in the past. Now we can see that it's currently executed. So once it's fully executed, we can take a look at the telemetry data to see how long it took. All right, we can see that it ran for 55 seconds. If we click into the query profile and then go into the query telemetry, span data missing. Oh, let's see. Let's go into traces and logs. All right, so if we go into this trace, or if we go into this trace, let's see, I'm gonna compress a couple things just so it's easier to read. Okay, so we can see that loading the data in from the training table took 366 milliseconds, feature engineering, very little time, defining the pipeline, 0 milliseconds. So splitting the data took 827 milliseconds, and then the actual fitting of the pipe, so that includes the data engineering steps and the cross validation, the grid search. It only took 25 seconds to do a grid search on 9 hyperparameters. I think that's pretty quick. Obviously, it's not 10,000 records isn't a ton of data, but I think it seems like it performed well, right? And then the model evaluation or the predictions took 13 seconds, and saving the model to the model registry took 12 seconds. Snowflake telemetry is a relatively new feature. I think it's really great because we're able to see exactly how long each process took, and that gives us some insight into Snowflake's performance. I do really quickly want to take a look at the model in the model registry. So if we go to ML Pipe, Models, and click on our insurance charges predictions model, we can see a little bit of information about it. So we can see that there's one version. Once we go into this version, we're able to see how big it is, what version of Python it ran on, the metadata about it. So it has its mean absolute percentage error is only 2%, mean squared error is 148,000, and the associated functions with this model and the input that those functions need to receive. And so whenever predict is called, these inputs need to be passed in. We can take a look at lineage. Currently there's nothing there, and we can look at the files that were used to create this model. Okay, now let's take a look back at the big picture and kind of analyze what we've done so far. We created the task that runs the stored procedure. We've actually trained a model, so let's check that off. We've actually saved it to the model registry, and now we are ready to perform these things down here. So let's start by heading over to our SQL file where we are creating this pipeline. Okay, we're going to start by creating the landing table where the streamed in records would land. Now we're going to create a stream on that landing table, and a stream is basically a table with a couple extra columns. Like we said, a table that whenever there are changes on the landing table, those changes are reflected in the stream table, basically. And we'll take a look at what that looks like in a second. We're also, well, first let's check these off. Created the landing table, created the stream, and let's create the gold table for the records, for the completed records and their predictions to go into. Okay, so now what we're going to do is insert a couple of records into the landing table and see what that looks like in the stream. So insert into the landing table all of these columns from the incoming data source, limit 10. Okay, once those 10 records are in, we can take a look at what that looks like in the landing table first. So let's just look at the landing table. We can see, yeah, we have all the information about the customers, including their charges, 18,000. Now, in real life, the landing table wouldn't have these charges likely, where we would be predicting them. But in this case, we have them, and we might as well, we're gonna keep them through the pipeline. We won't be using them, we basically have the answer, but we're not gonna be using it. We're going to save it for later on to compare actual versus predicted charges. So this is what it looks like in the table. If we look at the stream, we can see that it's really basically identical, but with the addition of these last three columns, the metadata action column, updated column, and row ID. And these are used just to show what happened on the table. So these were inserts. It shows if it was an update, and it assigns each row a specific ID so that it can be tracked if that row gets updated or if that row gets deleted. Okay, now what we're going to do is create the stored procedure that will predict using the model and write those predictions to the gold table. Now to do that, we need to go to the Git repository, create in Snowflake, predict and write. Let's copy this file, and we can go to And then we're going to create a new SQL file, paste in the code, set our context. And if we want to, we can rename this to predict write sprock. And it's very similar to what we already wrote in the other stored procedure. And again, we're going to go back into the GitHub to look at the Python code in a little bit more of a pretty way. If we look at predict and write. Okay, with this stored procedure, it's a little bit shorter because all it's doing is grabbing data, doing predictions, aka running the pipeline, and writing that data to the table. So we'll start here. We read from the stream, which we do by just saying df equals session.table stream on landing. So we're accessing that stream where the action that happened was an insert. So any new records that are coming in, we are accessing those records. We then determine which categorical columns to do one-hot encoding with so that we can tell that to the pipeline. We do a little bit of data cleaning, and then we, again, create a model registry object so that we can run model registry.getModel, and we access the default model here. Sorry. So once the default model is accessed as model version, we're then able to just say results equals model version.run, and then we're able to pass in the data frame, and we specify the function name that we want it to run. So this is where the actual pipeline prediction is happening. So results is the data frame that represents all of the initial information about the person and the predicted charges. We then have some logic to write that data into the gold table. If they were updates, then we update the associated record in the gold table. And that's really all that happens here in this stored procedure. So let's go back to our stored procedure. Let's run this code. Okay, that took about 7 seconds to run. We can now see that we have that stored procedure saved as, let's refresh, predict write to gold. Okay. Now, if we go back to our machine learning pipeline main SQL file, I scroll down to where we just ran this file, we can now just call this predict write to gold and see it work on the data that we've already loaded into the stream. So to remind ourselves, we have 10 rows in the stream right now, and we can call this stored procedure to run on those 10 rows. Okay, so that took about 12 seconds to run. We can see that the output was a string that says 10 records were inserted. Now, if we wanted to check that, we could do that by clicking into the insurance gold, hovering over, and we can see that there are 10 rows. We could also run select star from insurance gold, and let's limit it to 100 just to be sure. And we can see those 10 rows. Now we have the metadata row ID, and we also have the real charges. So we retained that real charges column so that we can compare against the predicted charges. And we can see in most of these cases it came pretty close, 12,900, 12,600, 11,700, 11,000. So we can see that it's predicting about as well as we learned by looking at those error metrics. Okay, so we can see that the gold table has updated. If we go back and look at the stream, we query from the stream, we can see that there are no records in the stream anymore. In other words, we grabbed from the bucket and we emptied it, and we used those rows in the new table, and so now that bucket is empty. Just to see, let's load in 10,000 records into the stream. We can see, let's turn this into a count. Select count from landing table. We can see that there is now 10,010 records in the landing table, and in the stream there should be 10,000. Yeah. So I'm going to put this back how it was. Now let's call predict write to gold on 10,000 records. And once that runs, we should be able to see that there are 10,010 records in the insurance gold table. All right, so we can see that that took about 11 seconds. If we go into traces and logs, I'm going to open that in a new tab. We can see that predict write to gold ran. I'm going to collapse these to see a little easier. And so it took about 7.7 seconds, actually. Well, the part that we were tracking took 7.7 seconds. Reading from the stream, 162, standardizing values, some data engineering. Loading the model from the registry took about a second, and then running the actual pipeline took only 400 milliseconds. So this is on an extra small compute instance. We were able to run 10,000 records through the pipeline that did one hot encoding and the prediction with the XGBoost model in 400 milliseconds about. So super fast. Snowflake's machine learning runtime, Snowflake's warehouse runtime with Snowpark machine learning is, super fast. And then writing the actual records to the table only took 5.2 seconds. So very quick on a relatively small warehouse for a good amount of records. Now, if we wanted to, we could test kind of the updating mechanisms. I'm not going to do that right now, but we can see again, after processing those 10,000 records, there's nothing on the stream anymore. Now, here's where we can create the task that automates this prediction logic. So we can create or replace task, assign it to a warehouse. We can also schedule it for 1 minute and then set a condition here. So we say, when the stream on landing has data, then call predict write to gold. But anytime if there's not data in the stream, then nothing will run. So what that does is save us time and save us money on our compute. I'm going to run this. Task was created successfully. Let's refresh and look at the tasks so we can see predict write task. And again, we can alter it so that it is in resumed state. Now let's have it execute as a task. Execute task, predict write task. Okay, so it's scheduled to run immediately. Let's go take a look at it. We can look at the run history. And we can see that it was skipped because the conditional expression for task evaluated to false. Now, why was that the case? Because the stream, if we look at the entire stream, there's nothing on it, right? Let's insert 100,000 records, okay? Let's just double check. The stream on landing has 100,000 records. And if we look at when it's scheduled to run, well, let's just run it ourselves. Execute task, predict write task. We refresh it. So now we see that it is executing. And it should take, I'm going to make a wild guess and say that it'll take 15 seconds. Oh, okay, 14. Sweet. So if we go in, I'm about to die. If we go in and look at the telemetry, I've noticed that it takes a second for the telemetry to load. And if it's not in the query telemetry on the query view, you can often find it in the traces and logs. But you have to give it sometimes takes about a minute to load. The trace for running that last task appeared. Again, I'm going to collapse it a little. And we can see that it's very similar, reading from the stream, not much time, standardizing a little bit more time, loading the model takes about a second, and then running the actual pipeline took 398 milliseconds. So it's crazy. This is 10 times more records, but it took the exact same amount of time to run the actual pipeline. I think so. 398 milliseconds on this one, and the last one was 393 milliseconds. So it's just crazy fast running the actual pipeline. And then writing the actual data took 6.8 seconds this time with 100,000 rows. Last time it took 5.2 seconds. So It took about two more seconds to write it because it was 10 times more data. So let's check back in with our diagram. We have created the goal table, we created the store procedure and the task, and we performed model inference on the stream. So now our whole pipeline is built out, and we have ourselves an automatic retraining and model inference pipeline fully built in Snowflake using a lot of the newest technologies that they have available. And so just to wrap up, let's take a look again at what we covered in this video. We looked at the Snowflake UI, running some SQL commands, Snowflake Notebooks, Snowflake ML, model registry, creating streams, stored procedures, and tasks. I hope this video was useful for you. I hope you learned a lot. I know that when it comes to machine learning and data science and data pipelines, that there are a lot of different ways to get the same thing done. And I'm sure that you had some thoughts on how I did things. I'd love to know what you thought in the comments so that we can continue learning from each other. So thank you so much for watching. Have a great day.